Hey y'all, I'm Sir Pinkbeard, and welcome back to the second video in my Learn to Code in C# .NET 5.6 series. If you want to pick up from where we left off in the last video, you can click on the card right up here. It will take you to the playlist, and you can watch all of the videos in succession, especially if you're watching this long after this video has come out. Otherwise, in the first video, we covered topics like interacting with Visual Studio, interacting with a console, the anatomy of a program, variables, how to manipulate strings, and how to make decisions. And we also did some work on our text-based RPG that we're building throughout this course. In today's video, we're going to cover the following topics: loops, enums, casting, variable scopes, switch cases, math, how to do math, really, and methods, and we're going to continue building our text-based RPG while we talk about those things. So just like the last video, you're going to want to take some notes, and you're going to want to follow along, so if you're ready for that, let's get started. At the end of the last video, we asked our user for their name, then for them to confirm it, and if they weren't happy with the name they gave, we gave them the option to try again. After we added it, I posed a question: what would happen if the user messed up their name again? Well, the obvious answer is we have to provide them some ability to re-input their name. And at first glance, you could say that all we have to do is copy and paste our code again. But we've already added it once, and there's no telling how many times a user might decide to change their player's name, so that really won't work. So the solution to this problem is something called a do-while loop. The do-while loop allows some code to be executed once and then re-executed if some Boolean expression evaluates to true. So let's add the do-while loop into our code, and then we'll talk about the other loops available in C#. Looking at our code, we can see that we will need to repeat the confirmation statement as well as the re-input statement. So everything from here to here must be repeated if the user doesn't like the name that they chose. Now that we know where the loop will go, let's go ahead and add it. Start by adding the do keyword and then a set of squiggly braces. Please note that everything inside the squiggly braces is known as a loop body. Then after the closing brace, add the while keyword and some parentheses. Then highlight the code we need to move into the loop body and hold the Alt key and press the Up key until all of the code is inside the do while loop. Then hit Tab to move it over and maintain proper formatting. Now our code will execute once, and while the expression in the while statement is true, it will repeat. But we need to create the Boolean expression to be evaluated. Let's add a bool variable called nameCorrect above the do statement, and then inside the loop, let's set nameCorrect to true. The reason we're setting it inside the loop is so that each time the loop re-executes, we reset the value of nameCorrect. We want the loop to execute until nameCorrect is true, so by resetting it to true, we are saying that this will be the last iteration of the loop. However, if the user doesn't like their name and doesn't answer with an uppercase or lowercase y, then we need to set nameCorrect to false so that the loop repeats. Then we can add the Boolean expression of not nameCorrect to the while statement. Now let's go ahead and run our application and see this loop in action. I'll enter my name incorrectly and then hit enter. I'll say it's not my name with the N key, and then I'll enter my name correctly and confirm with Y. At this point, the loop stops repeating, the last write-line statement is printed, and the application then stops running. Now we have two other loops that we'll need to talk about, and those are the while loop and the for loop. The while loop is sort of like a looping if statement, because if the Boolean expression evaluates to false, the loop may never execute the code contained within its loop body. In our example, if losses is greater than or equal to max losses from the very beginning, the loop would never execute. However, in its current state, the while loop will determine if losses is less than max losses, and then will execute the code contained inside. Once it's reached the end of the loop body, the loop will then reevaluate if the Boolean expression is still true. If it is still true, the player will continue playing, and if it's false, the loop will not repeat. The third loop is the for loop. This differs from the while loop and the do while loop in its purpose, because the for loop is meant to do something a set number of times. Because of that, the for loop syntax looks slightly different than the other two. The for loop starts with the for keyword, but inside the parentheses we can see three different sections separated by semicolons. The first section is known as the initializer section. This section is only executed once throughout the entire loop and is typically used to declare and initialize a local loop variable. In our case, we have int x equals 0, so we're creating a variable named x for the loop to use. While we'll talk about variable scope later in the video, just know that whatever variables you initialize inside the for loop will only work inside the for loop due to variable scope. Again, we'll cover that a little later in this video. The second section of our for loop is the condition section. This is where we'll put our Boolean expression. Like the other two loops, if this expression evaluates to true, the loop will perform another iteration. In our scenario, we'll keep looping while x is less than 100. The final section is the iterator section, which defines what will happen after each execution of the loop body. Generally, this is where we would increment our counter variable to ensure that we don't have an infinite loop on our hands. So you can see that we use x++ to increment the counter variable. So here's how this loop actually works as a step-by-step. First, the loop will initialize the x variable. Then it will check if the Boolean expression is true. If it's true, the loop will perform the first iteration of the loop body. After the first iteration of the loop body, it will perform the increment step of x++ and then check if the Boolean expression is still true. Since it will be, it'll re-execute the loop body and then increment x and then check the Boolean expression and so on until the expression is false. Now, when working with loops, you need to make sure that you always have an exit condition, meaning a scenario where the loop's Boolean expression will evaluate to false. If you don't have that, you'll end up with something called an infinite loop, and your code will never finish executing the loop body. For example, say I remove losses ++ from this while loop. Without the increment statement, losses will always be less than max losses, and this while loop will continue until I manually shut down the application. Infinite loops can happen to the best of us if we aren't careful, so make sure you're always providing an exit condition for whatever loop you create. Alright, that's pretty much everything you need to know about loops, so now we can move on with our game. The next information we need to know about our player character for our game is what class they want to play as. If you're not familiar with standard RPG classes, we'll give them the option of playing as a wizard, a fighter, or a ranger. So go ahead and ask that question using CW tab hotkey to save yourself some typing. Then we'll go ahead and add a console.write statement prompt to have them input the number of their choice. Now we need to provide them with some options to choose from. So once again, let's do CW tab and then provide the first option. Let's use number 1 to represent the fighter class, and then you can do Control-D to duplicate a line of code. So I'll duplicate that line twice and make option 2 equal to wizard and option 3 equal to ranger. Now that we've given them the options, we need to take in the number of their choice. And just a quick side note, when working with users, you want to make it as easy for the user as possible to interact with your application. So by forcing them to input a number instead of the name of the class, you're making their experience with our application better because there's less potential for things to go wrong. For them to input the number, we'll need an int variable called classChoice, and let's set it equal to console.readline. When we do that, we'll get an error, because console.readline returns a string of characters which cannot implicitly be converted into an int value. So to fix that, let's wrap the readline inside of one of the built-in convert methods. Before the console.readline statement, add convert.toInt32, because the int variable is a 32-bit integer if you remember from our last video. Add an opening parentheses before console, and then a closing parentheses before the final semicolon. Now, we could leave it like this, and that would be totally fine for the small scope of our application, but the numbers 1, 2, and 3 don't inherently mean anything in our code, and since we'll likely provide a list of options and receive number choices in return later on in our application, the numbers won't help us understand if we come back to this application later on. So to make the code more readable, we need to make something called an enum so that the values that we're using for the choices will inherently mean something the next time we come to the code and read through it. To create a new enum, select the project name, right-click on the selected project, and then Add and Class. Now let's call this D&D class and then hit Add. Visual Studio then sets up a new class file called D&D class and gives us the internal class D&D class template. Now let's change the class keyword to enum, which changes this block of code from a class type to an enum type. An enum, short for enumerated value, is a custom variable type that has a specified range of values that you set up. All values in an enum have a backing type that is numerical, and what that means is that every value you set up in your enum equals some number. By default, that backing type is an integer, but we can change it by adding a colon and then any of the integer types we want next to the enum type header. So let's set the backing type of this enum to byte, and then add in some values for this enum. We'll start with fighter, which was option 1. So after we type in fighter, let's set that equal to 1. What this does is create the fighter value and sets the backing field of that value to 1. Then we can add in wizard, which will equal 2, and ranger, which will equal 3. Notice how each value has a comma after it, except the last value. That's because in C#, when you add multiple values to something, they are separated by a comma and not a semicolon. And the last value does not have a comma after it because it's the last value. Now here's the thing. Enums usually start at 0 for their first value, and they will auto-increment for each new value. But you can change that like we did by specifying the backing values as we did. But we don't actually need to specify all of them. We can simply specify the first one and then remove the assignment code for wizard and ranger. And then we can see that because enums auto-increment, wizard is still equal to 2 and ranger is still equal to 3. Now that we're using an enum, let's go back and fix the class prompt. To fix it, we'll need to add the string interpolation $sign to the front of the string literal, and then replace the number and the text option with the correct enum value. So let's replace the 1 with D&D class fighter. This will only give us the name of the enum value, so to get the backing value, we'll need to cast it to a byte. Now we can cast by adding parentheses byte in front of the D&D class fighter. Now before I go any further, let's talk about casting and type conversions and what that all means so that you can fully understand what it is that I just did. At its core, casting is just a way of converting one data type to another data type by putting the data you're trying to cast it to in parentheses before the data you're trying to convert. The reason casting exists is because C# is a strongly typed language, meaning that an int variable can only ever hold int values. That's why we had to add the convert.toInt32 around the console.readline in order to get our original class choice, because strings do not implicitly convert into int data. So that convert.toInt32 method casts the string we get back from the console readline into a usable int value. But casting is just a small part of a larger group of operations known as type conversions. There are currently 4 types of type conversions, but we're only going to talk about 2 of them: implicit conversions and explicit conversions. An implicit conversion is a type conversion where there is no special syntax needed because the conversion always succeeds, and no data will be lost. If you assign a byte variable to an int variable, this is an implicit conversion, and it will always work perfectly because an int variable can hold all of the data value ranges of a byte. So if you're assigning a small capacity integral type to a larger capacity integral type, the implicit conversion will always succeed. An explicit conversion requires casting, because in these scenarios, information may be lost in the type conversion, or the conversion may not succeed for other reasons, like if the user typed a word instead of a number when we asked for their class choice. So in our example code, you can see that we have a double with a decimal point, and we cast that double variable to an int. Since an int type cannot hold decimal values, the information will be lost, and we print out only the remaining integer. Keep in mind that casting only tells the compiler that you are okay with some data potentially being lost during the type conversion. But if the conversion doesn't actually work during runtime, the application will throw an invalid cast exception, causing your program to break and stop working. Bringing it back to our program, in order to get the backing value of our enum and present it as a number choice to the player, we need to cast the enum to its backing type, which is a byte in our case. After we cast it, let's also replace the fighter text with the enum as well. The reason we do this is, let's say later on I decide I don't like the fighter class and I want to change it to a paladin class instead. I can simply select the fighter value, hit Ctrl-R twice, and rename the value from fighter to paladin, and the value will change in all of the locations it's used. This way, I don't end up removing the fighter class and having to look through any text where it's hard-coded to make sure I don't have a reference to a class that doesn't exist. Anyway, let's undo that because I want to keep the fighter class for now and remake the other options using enums as well. So remove the other 2 options and then duplicate the fighter line twice using Ctrl-D. From there, simply make line 2 the wizard and line 3 the ranger. Now we still want the user to input a number, but instead of storing it in the int class choice variable, let's change it to a D&D class type so that we can continue to work with the enum. Remember that the backing type for our enum is a byte, so let's change the convert method from int32 to byte, and then cast that converted value into a D&D class type. And now we can successfully get the user's choice as an enum. Now that we have their choice, let's have the user confirm their choice by adding a write-line statement, and then we can copy and paste the confirmation code from the name confirmation section. When we do that, an error appears on line 21 because two variables in the same scope cannot have the same name. Now, variable scope overall is a bit more complicated than that, so let's go ahead and talk about it. There are 3 levels of variable scope: class level, method level, and block level, and each one of those has a smaller scope than the previous one, meaning that while class level variables can be used by any applicable methods and blocks contained inside the class body, a method level variable can only be used inside the method that creates it and any blocks that that method contains. And block level variables only exist in the block it's created in. Up to this point, all the code we've written has been method level code because it all exists within the main method. But if we add a variable above the main method and still contained within the program class body, we can create a class level variable. Then if we duplicate that line of code, we'll see an error saying that the program class already contains a definition for that variable name. This class variable can be accessed and used by any method contained inside the program class. Next, we have the method level variables like name, which can be used by the method that creates it and any blocks that it contains. That's why we can access the name variable inside and outside of the do while loop, but only inside of the main method. And finally, we have block level variables like answer, which is created inside the do while block. When we create a block level variable, it only exists inside the block that defines it. So our string answer variable created inside the do while block only exists inside that loop body, and it will cease to exist when the flow of control leaves that loop body. You should know that a block of code is denoted by a set of squiggly braces, but variable scope works differently if that block of code is named, like with methods and classes, versus unnamed blocks like loops and if statements. So if we have a method level variable called answer and a block level variable called answer contained inside the same method, the block level variable cannot share the same name as the method level variable. The solution to this error is simply to encase our D&D class choice and confirmation in a do while block just like we did for the name. For this loop, we're going to need a bool variable called classCorrect, which will control the loop, and then we'll make sure it's set equal to true at the beginning of the loop. Then let's grab the confirmation code from our name loop and paste it into the class choice loop, making sure to adjust it so that if the answer doesn't equal y, we set classCorrect to false. And finally, we can set the loop's expression to be while not classCorrect. So that's pretty much the basics of variable scope. There is one more advanced thing about variable scope that we'll talk about in the next video, but until then, this is all you need to know. And honestly, variable scope is not that big of a deal because the compiler will let you know if there are any errors. Now that we've got our player's name and class choice, let's have the player's character base stats adjust based on their chosen class. To start off, we're going to need a few int type variables to represent their stats. So create an attack, defense, magic, and accuracy variable and set each of those base values to 5. Instead of taking 4 lines to declare all 4 int variables, we can create them on the same line and separate them with a comma because they're all the same type. Now this only works because they're the same type of data, so if they were different types, you'd have to create them on different lines. Now that we have their stat variables, we can adjust them based on the class choice that they chose. To do that, we could use an if statement and check if class choice is equal to fighter, but when we do that, we have a small problem because the class choice variable has a block level scope and doesn't exist outside the do while loop. To fix that, we just need to create the variable outside the loop and then assign it inside the loop. With our error resolved, we can adjust the stats. Now, like I said, I could use an if-else chain, like I've currently got set up, but writing all that out will get tedious, so let's talk about the second type of decision-making tool we can use, which is called the switch statement. Now the switch syntax is a little different, but it starts out with the switch keyword. Then in the parentheses, we need to have a variable to switch on. So let's use class choice. and complete the switch block with a set of squiggly braces. Now inside those squiggly braces, we'll use the case keyword to signify a potential value, and Visual Studio is recommending I use case dnd.fighter with a colon at the end. The case statement is the equivalent of saying that if the value of class choice equals fighter, then we'll do this code after the colon. Then I'll add a comment to tell me what I'm going to do in this section, and the break keyword. In C#, each case statement that contains any code must end with a break statement. When the break statement is executed during runtime, the switch statement will understand that the work is now done, and flow of control will leave the switch statement. This can also be used inside loops to end them early. Now that the fighter case is set up, let's quickly set up the wizard and ranger cases. Since our enum has a set number of potential values, we could leave the switch case like this. However, let's say we had more options and the player didn't choose one of the 3 cases. Well, the switch case has a default section where we can make something happen if they choose one of the other options. So if class choice isn't equal to fighter, wizard, or ranger, the default section will execute. The switch case is able to save you some writing, especially in its newest form, which I didn't show, but it saves you some writing if there is a limited number of options that a value can be. If there is not a limited number of options, or you need to have a more complicated Boolean expression, you're better off using an if-else chain. Anyway, now that we've got our switch case in place, let's learn about how to do math in C# so that we can actually make changes to the variable's values. In C# we have some math operators, and they're broken down into unary and binary operators. The unary operators are increment, decrement, plus, and minus, but plus and minus only mean positive or negative when they're in unary form, not addition or subtraction. The increment operator increases whatever operand it is attached to by 1, and the operand must either be a variable, property, or an indexer, though generally you'll just use it with a variable. The increment operator supports both prefix and postfix notation, and what I mean by that is that you can place the plus plus before or after the variable, and the variable will be incremented, though the incrementation will take place in a different order in prefix or postfix. For example, in this code we can see the increment operator in postfix notation, meaning it's after the variable. When the increment operator is in postfix notation, it means that the value of the variable will be used first, and then the variable will be incremented. This is why the second line prints 3, because the value of x is printed before x is increased. However, in prefix notation, the value of the variable is increased before it is accessed, which is why line 2 prints 5. Now, the decrement operator works basically the exact same way as the increment operator, except that it subtracts 1 instead of adding 1. Then we have the unary plus and minus, and again, this is just positive or negative. So now that we know the unary operators, let's talk about the binary operators. The binary operators are used to perform some operation using 2 operands, and are the multiplication, division, addition, and subtraction operators. Let's start with the multiplication symbol. The multiply symbol is the asterisk key, and like in normal multiplication, you'll need an operand on both sides of the asterisk. The division symbol is the /, and it will divide what is on the left by what is on the right. You should know that there are 2 types of division in C# though. Integer division and floating point division, or real division. With integer division, any and all of the decimal places will be truncated and lost. So if we look at this example code, the actual answer from 13 divided by 5 is 2.6. But because we're working with 2 int literals for the equation, C# will perform integer division, and will only print 2 or -2 based on the equation. So if you're looking to do real division, you'll need to make one of the operands into a floating point value, which you can do by casting it or adding the literal suffix for one of the floating point types. Then we have addition and subtraction, and these work just like you'd expect them, adding or subtracting from left to right. Now we do have a final binary operator, which is known as the modular division operator or the remainder operator, and this is represented by the %. The remainder operator will compute the remainder after performing a division operation. So 5 remainder 4 will return 1, because the remainder of that division is 1. Generally, you use this operator with integers, and there are some special rules for using it with floating points, but I've never had a reason to do that in 10 years of coding. So if you come across a need, you can just look up what the rules are for doing remainder with floating point values. So, now that you've seen how the operators work, let's talk about a shortcut for performing the binary operations known as compound assignment operators. For all of the binary operators, we have the ability to use a compound assignment operator to shorten the code we need to write. Let's say we have an int x that is equal to 2, and we need to add 9 to the value of x. we could write x equals x plus 9, and that certainly would accomplish the task, but that's a little cumbersome. Or we could write x plus equals 9, which is the shorthand way to add 9 to x. All of the binary operators can be used in this way, where operator equals and then some value to add, subtract, multiply, divide, or find the remainder of, and set it to the value of the variable. There are two final things that you need to know about math in C#. The first is that the order of operations pretty much works the exact same as math in real life, where multiplication and division are given precedence over addition and subtraction. However, you can add parentheses into your equation to prioritize certain sections of your equation first. And the second is what happens when you add or subtract values outside the range of that data type. The answer is different for integer types and floating point types, but for integer types, the answer is that an overflow issue will occur. Now, this won't break your program, but it will cause weird things to happen in your data. For example, in our code here, you can see that a is equal to the maximum value of the int type, but if we add 3 to it, we actually get a negative number. That's because since ints cannot hold more than its maximum value, when you add a value to the maximum, the variable overflows and starts at the minimum value again, and then continues to add the numbers. This is the default operation, and it's called an unchecked context. However, you can prevent this from occurring by using the checked keyword, in which case instead of overflow logical problems, you'll just get an exception. Now, if you try to overflow a floating point type, you'll just get the value infinity. Now that we've covered all of the math you need to know for coding, let's go back to our program and adjust those stats. Let's use some compound assignment operators to actually do what we told ourselves to do in the comments we left in the switch case. For the fighter, go ahead and add 2 to the attack, 1 to defense, and subtract 2 from magic and 1 from accuracy, or you can adjust the stats how you want. For the wizard, I'll add 2 to magic, 1 to accuracy, then subtract 2 from attack and 2 from defense. And finally, for the ranger, we'll increase the attack and accuracy by 2 and decrease magic and defense by 2. Now, at this point, we have learned a ton of information in this video, and if you're still with me, congratulations, you're doing great. And not only have you learned a ton, but we've also taken in the player's name and class choice, and we've adjusted their stats based on their class choice. But we've still got one more topic to cover in this video before we're done. Now, as a software developer, it is in your best interest to write code that is easy to understand. And one of the principles for writing easily understandable code is the principle of single responsibility. What that means is that a single block of code, usually meaning a single method, should only have a single responsibility. The main method in a console application is only meant to control the application, but if we look at our main method, we can see it already has 3 tasks that it's responsible for: getting the player's name, getting the player's character type, and adjusting the player's stats. That is simply too many things for the main method to do, so what we need to do is break the main method into smaller methods that are focused on doing only one thing. So let's talk about methods and then refactor our code to better follow the single responsibility principle. A method in C# is just a named block of code that you can call over and over again to accomplish some task. And according to the single responsibility principle, it should only do a single task. Now, in our application at the moment, like we said, we only have a single method, the main method, and it's doing too much. Now, the main method is a static type void method, and it takes an array of strings as a parameter. Now, that does not mean much right now because we haven't covered methods, but just know that that whole line there is called the method header. Now, here's how a method header gets broken down. We'll start with the access modifier, which isn't present here, and we'll cover in the next video. Then there's the static keyword. We'll go more in depth about this as well in the next video. Then we have the more important part, which is the return type and the name followed by parentheses. Whenever you create a method, you are going to need to specify the return type, the name, and add parentheses. Then we add parameters to the method inside the parentheses. Now, a method can have 0 or more parameters, but regardless of how many parameters the method has, the parentheses are always needed. Now, let's talk about the parts of the method header a bit more in depth. There are basically 2 kinds of methods: those that just do things, and those that do things and then return some value. Methods that just do something are called void type methods. The main method is one of these methods because it runs the application and does not return a value when it's finished executing. The methods that return a value can have a return type of pretty much anything as long as it is a defined type of data, like the built-in primitive data types or the custom D&D class type that we created. Now we'll create 2 of these methods that return values once we finish the other parts of the method header. But we've used the readline command in the past and in our code, which gets the information from the console and then returns that value as a string. So you should be at least somewhat familiar with the concept of how to work with methods that return values. Some methods have parameters, and a parameter is nothing more than a variable that the method declares in its header, and that is used to accomplish whatever task the method is meant to do. Each parameter has its own data type, and when you call the method to do some work for you, you need to provide it the information that it requests in its parameters. The information you provide is known as an argument. Now we've done this a few times already with the WriteLine statements. See, WriteLine takes in a string value parameter, and when we call the WriteLine statement, we provide it an argument of the string literal text that we want printed to the console. If you take a quick look at the documentation that appears, you'll see that this method has 17 overloads. But what does that mean? So overloads refers to something called method overloading, and method overloading is the ability for us to create a method with the same name, but a different set of parameters. As long as no method has parameters of the same type in the same order, you can create an overloaded method. Now that's enough about methods for now. We'll cover some more information about them in the next video when it becomes relevant, but for now, let's go fix our main method. Let's start by creating the method for getting a player's name. Below the main method block, but still within the program class body, let's add a new method header. So type static string create player name with no parameters, and then add a set of squiggly braces to signify the new method body. Now you can hit enter after adding the squiggly braces to have Visual Studio format the braces correctly. To fill the method, just cut the name section from the main method and place it inside the new method. Since our method is a string type method, we need to return a string. So after the while loop, add return name semicolon. This method will now handle getting the correct name from the user. So let's call this method from the main method and store the response in a variable. To do that, let's add string name equals create player name on line 11. Now separating our code like this has a few benefits. The main method becomes easier to read because there's less code in it. We now know that we can also get the player name from create player name, and the code becomes more organized, which is helpful if we have any issues that come up and we need to troubleshoot. Now let's do the same thing for creating the player class and add in a new static method below the create player name method called choose player class that returns a D&D class value. Then cut the code that chooses the class and paste it in the new method, and return the class choice variable. Just like with name, we need to call choose player class from the main method so that we can get the player's class. The last thing I want to talk about is why I made these methods static. The reason for this is pretty simple. A static method, like the main method, can only ever directly call other static methods. However, non-static methods, which are just methods without the static keyword, can directly call both static and non-static methods. Since we're currently running the application from inside the main method, we have to make the other methods static in order for them to be accessed by the main method. So if I remove this static keyword, you can see that the main method can no longer access the method. Anyway, that's all you need to know for now about methods. Alright y'all, if you made it to this point in the video, give yourself a pat on the back. You have downloaded a ton of information into your brain, and you have really done well with this video, especially if you've taken some notes and followed along throughout the entire thing. Now, if you're enjoying learning the process of how to code and building the text-based RPG like this, consider liking the video and subscribing so that you can continue the course when I drop the next video. Now, if you're watching this long after this video series has come out, you can click on the cards here or the video tiles here to get the next video in the course or the entire playlist. Otherwise, guys, I'm Sir Pinkbeard. Thanks for watching, and I will see you guys in the next one.